Namaste students, welcome to my channel Sumanth tutorial. If you have not subscribed yet, please subscribe my channel. Along with that one, don't forget to click on the bell notification. Don't forget to like, comment and share. Thank you. Yes students, in this session, I am going to explain you the concept of sound. In that specifically, reflection of the sound and the echo. So let us start from the basic. What is the concept of the sound? See here, sound produces when the object vibrates. Very simple. Whenever the object vibrates, it produces the sound, and this sound propagates in the form of compression and rarefaction. See here, compression, rarefaction, compression, rarefaction. How the waveform will be. So I am going to show. See here, compression, rarefaction, compression, rarefaction. So it is very clear that the sound wave will propagate in the form of compression, rarefaction, compression and rarefaction. But one thing you should note it down, that this sound wave cannot travel in a vacuum. Very important one. Why? Because sound is a mechanical wave. It needs a medium for the propagation. That may be the air. So if there is no medium, the sound cannot travel. Sound can travel either in a solid or in a liquid or in a gaseous medium. But sound cannot travel in vacuum. So I said sound cannot travel in a vacuum, and these type of waves are called as mechanical wave. So I think the concept of mechanical wave is clear to all. Then see here, I said the sound wave. But what is wave? Wave is a periodical disturbance occurs in a medium. You need to note down the definition. What is the wave? Wave is a periodical disturbance occurs in a medium. So let us study what are the parts of a wave. So let me take a simple wave represented in terms of x and y axis in the form of crest and a trough. Yeah. See here students. So this is the graph of x-axis versus the y-axis. See here, this is 0th position, and mark it as +5 and -5. So the maximum displacement of a wave from the mean position is called as amplitude of the wave. See here, this displacement is called as amplitude. I repeat, amplitude is the maximum displacement of the wave from the mean position, and the unit of amplitude is meter. Okay, so amplitude, yes. So the unit of amplitude is meter. So that may be for the crest or that may be for the trough. The amplitude of the wave remains the same. Here, this distance. Clear? So I repeat, the maximum displacement of the wave from the mean position, that is amplitude. Next, one crest and one trough is called as one wave. So what is one wave? One wave which includes a crust and a trough. And the time taken by the wave to have one crust and one trough, that is called as time period, represented by T, and the unit is second. So what is the time period? The time taken by the wave to complete one cycle or one wave. Now, the distance between the consecutive crust or the consecutive trough is called as the wavelength. I repeat, the distance between the consecutive crust or the consecutive trough is called as the wavelength of the wave, and this wavelength is represented by lambda, this symbol, and the unit is meter. So, if the number of cycles is coming, the number of wave is coming in the wave, but in 1 second, how many waves it is coming, that is termed as frequency. Very easy definition. What is frequency? The number of cycle in 1 second. In 1 second, how many waves is going to come? That is called as frequency. And the unit of frequency is hertz. Clear? Amplitude, time period, wavelength, and frequency. Yes, students. Now I will write one equation. Observe. V is equal to F lambda. V is the velocity of the sound wave, F is the frequency, and lambda is the wavelength. I request you to please make a note on this one. V is equal to F lambda. With this relationship, we can find out the value of velocity, or F is equal to V per lambda. We can able to find out the frequency, or lambda is equal to V divided by F. We can able to find out the wavelength. Yes, students, I said the concept about the mechanical wave, right? So I said the mechanical waves are the waves which needs a material medium for the propagation, and this mechanical wave will have two types. One is longitudinal, another one is transversal. So what is longitudinal wave? If the vibration of the particle is along with the direction of the wave propagation, that is called as the longitudinal wave. For example, we can take it as sound wave. This sound wave is a longitudinal wave. Then what is a transversal wave? If the vibration of the particle is perpendicular to the direction of the propagation of the wave, that is called as transversal wave. You can take the example of electromagnetic waves. So electromagnetic waves are transversal in nature, but sound waves are longitudinal in nature. Yes, students, now I am going to tell the types of sound waves based on its frequency. Means based on its frequency, how we are going to divide the sound waves. Broadly, we classify the sound waves into three categories. First one is infrasonic. Second one is audible range. And the last one is ultrasonic. If the sound wave having the frequency less than 20 Hertz. That comes under infrasonics. If the frequency of the sound wave lie between 20 Hertz to 20 kilohertz, that is comes under the audible range, and ultrasonic, which is more than 20 kilohertz. Now let us study about the reflection of the sound wave. Means when the sound wave is traveling in a medium, strikes the hard surface, it's bounce back. That process is called as reflection of the sound wave. In other term, we used to call it as echo. So what is echo? The multiple reflection of the sound wave is called as echo. Listen to my words very carefully here. If the reflected sounds merges with the original sound, that we cannot call it as echo. So there should be a distinct sound wave which is separated from the original sound, that is called as an echo. If the echo is prolonged, it is continued, that process is called as reverberation. Clear? When the sound traveling in a medium, when it is hit the reflector, it's bounce back. But the question arises, everywhere the reflection is going to take place? Or is there any particular condition? Yes, there is a particular condition. Everywhere we cannot able to hear an echo. But what are the condition? How we can determine it? So this is the minimum condition required for the occurrence of an echo. We can find out with a small formula, that is D is equal to Vt divided by 2. So what is D represents here? Distance between the source and the observer. V is the velocity of sound in air. T is the time. So if we substitute the value for this, we come to know that what is the minimum distance required for the occurrence of an echo or the formation of an echo. See here, we know very clearly the perception time of the ear is 0.1 second. And the velocity of the sound is 340 meter per second. Then find out the distance. D is equal to 340 into 0.1 by 2. After calculation, we got the value of D as 17 meter. So means the minimum distance required for the formation of an echo is 17 meter, and the reflector must be sufficient large size so that it can reflect the sound wave. Its size must be more than the wavelength of the sound wave. Along with that one, the intensity of the sound must be in such a way that it can reflect back and it can be heard very clearly. So, let us study the concept about the uses of the echo. With the help of this process, there are many things that we can easily find out. The depth of the ocean, echo ranging, sonar, and even in a medical field. So let us study how this echo help us in our day-to-day life. First thing, we are going to select the ultrasonic sound. Why we have selected this ultrasonic sound? Why we have selected this ultrasonic sound wave because it is having such a characteristics. First one, it can travel undeviated to the longer distance. Second one, it can be confined to a narrow beam. And most important, it will not going to observe very easily. Now I will explain one of the application, that is sonar. What is the abbreviation of the sonar? Sound, navigation and ranging. How it works with a simple diagram I will show. So let me draw about this is the depth of the ocean. Okay, see here, this boat is provided with a device called as transmitter and a receiver. What the transmitter will do, the transmitter will transmit the ultrasonic sound wave. When it is reaches the depth of the water, then it reflects back and that is received by the receiver. So the transmitter will going to transmit the ultrasonic sound wave. When it reaches the depth of the seabed, imagine it is a sea, so it reaches the seabed and it reflects back. So it will go in this direction, it will come back in this direction. So when it is reaches, it is received by the receiver. The time will be noted down and we know the formula, that is D is equal to V to T by 2. With this, they can find out what will be the depth of the ocean. And this method is called as echo ranging. I repeat, the method which has been used to find the depth is called as echo ranging. And also you might have observed the bats can fly during the night time unerringly. How it is possible? See, these bats will also produce the ultrasonic sound. When it is reaches the hot surface, it bounces back. By observing the obstacles and receiving, so the bat can easily find out, so there is an obstacle. So it will change its direction and it can fly where it is very clear. Not only that one, even the dolphins too. So the dolphin also uses the same method. In a medical field also, we are using this ultrasound. So to image the human organs like liver, we are going to use this ultrasound. We call that process is called as ultrasonography, where we can imagine the internal organ of the human like liver, womb, kidney, like that. And along with that one, to take the image of the heart and to study that one, we are going to use the method called as echocardiography. So let us solve few numerical based on the content. It is like this. A man standing before a cliff fires a gun. A distance from the cliff will be around 48 meters and he hears the echo after a few seconds. So we need to find that timing, but the speed of sounding air is 320 meters per second. To solve this one, we are going to use the formula, that is D is equal to Vt divided by 2. Now substitute the value which you know. So 48 is equal to 320 into time divided by 2. So 2 16s are 32. So T is equal to 48 divided by 160. So the value of T is equal to 0.30 second. See here students, in this question, a man is standing between the two vertical cliffs, shouts, hears the sound successively or he hears an echo successively 4 seconds and 6 seconds. What is the distance between the cliff? Here also we are going to take the velocity of sound in air as 320 meter per second. So here in this condition we are going to find the distance separately, and finally we are going to add it so that we are going to find out what is the final distance. So first condition, with the formula d is equal to Vt by 2, I will add here 1 and the 1. So d1 is equal to V into t1 by 2. See here, V is 320 into time, t1 is 4 seconds by 2. 2 2s are, so it is 640 meter, that is d1. This one. Clear? Now we are going to find the other distance d2. So d2 is equal to V into t2 by 2. So 320 into 6 divided by 2. 2 3s are, so it is 960 meter, that is d2. So we find out d1 and d2. So we need to find the total distance between the cleft. So I will take it as d will be equal to d1 plus d2. Substitute the value. D is equal to 640 plus 960. 1600. So 640 plus 960, 1600 meter.